Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals, right? And here we have an important problem from definite integrals in which we are going to use the method of substitution, right? So here we have the integral from 1 over e to e 1 over x sine x minus 1 over x dx, right? So let us call this integral as I. Now in order to solve this integral, we'll make use of the method of substitution, right? So method of substitution is a powerful method in integration, right? So let us substitute here, say t is equal to 1 over x, right? So here we'll make use of this substitution, that is t is equal to 1 over x, and if we differentiate both sides, what we will get will have dt over dx is equal to minus 1 over x square, right? Because the derivative of x raised to minus 1 is minus 1 over x square. So now we can write the value of dt over dx equal to minus 1 over x whole square, and for 1 over x we can write t, right? So here we have minus t square, so dx can be written as dt over t square, and here we have the negative sign. So now we have the value of dx as minus dt over t square, and now see here the lower limit is 1 over e and the upper limit is e, right? So when x is 1 over e, where e is the exponential number, so let us find the corresponding value of t, right? So when x is 1 over e, t is equal to 1 over e. So here we'll substitute x is equal to 1 over e, so here we'll get e, right? And when x is equal to e, we'll get t is equal to 1 over e, right? So when x varies from 1 over e to e, then t varies from e to 1 over e, right? So now we can rewrite our integral I in terms of t, right? So here we have the integral, and when x is 1 over e, we have here the lower limit as e, and when x is e, then we have the upper limit as 1 over e, right? And for 1 over x we can write t, and here we have sine, and then for x we can write 1 over t, right? So here we have 1 over t minus for 1 over x we can write t, and for dx we can write minus dt over t square, right? So now let us simplify this integral. So we have e to 1 over e. See here t and 1t get cancelled, so we can take this 1 over t here, and this negative sign we can take outside, and we have sine 1 over t minus t and dt, right? So now here we have to closely observe this integral, right? See, in the original integral we have sine x minus 1 over x, and here we have 1 over t minus t. So if we here if we make use of one important result from trigonometry, that is sine of minus theta is equal to minus sine theta, right? So what we will do, see we have sine 1 over t minus t, so let us take negative sign common from 1 over t minus t. right? So what we will get, we have minus t over t minus 1 over t, and now we have a sign of minus theta. For theta we can assume t minus 1 over t, right? So now if we apply this rule to this expression, then we can take this negative sign outside, so we have minus sign, and we can write t minus 1 over t, right? So now this integral I reduces to minus, we have e to 1 over e, here we have 1 over t, and for sine 1 over t minus t, we can write minus sine t minus 1 over t, right? Okay, so now here we have dt. So now this negative sign can be taken outside, so this negative and this negative get multiplied and we'll get the positive sign. So we have e to 1 over e, and we have 1 over t sine t minus 1 over t, and here we have dt, right? Okay, so now if we look this integral, and if we compare this integral with this one, then we see that this integral is similar to this integral, except the limits are interchanged, right? So now we can interchange the limits. So we'll have I is equal to a negative, and we can interchange, or we can shuffle the limits. So here we have 1 over e, and here we have e 1 over t sine t minus 1 over t dt, right? So here we have made use of an important property of integrals, definite integrals, that is a to b f of x dx can also be written as the negative of b to a f of x dx, right? So if we interchange the limits, the value of the integral becomes negative, right? So now we see that this integral is similar to this one, and by the dummy property, we can write a to b f of x dx is similar to or equal to a to b f of t dt, right? So we can write the integral a to b f of x dx as a to b f of t dt, right? So we can simply change the variable, right? So this integral is equal to I by this property. So we can now write I is equal to minus I. We can take minus I to this side, so we have I plus I is equal to 0. So 2I is equal to 0 and I is equal to 0, right? So the value of this integral is equal to 0.